Okay, folks, so let's talk first here about what the aperture numbers mean. So let's say that this is f22, and we say that because it is mostly closed, right? It's sort of a pinhole size. It's not going to admit many clusters of light. So we have light coming down and bouncing off the sun. We'll go ahead and use a yellow ray here for that, right? So as light comes down and bounces off the sun, it's going to bounce off in a whole bunch of different angles, and we're not concerned about most of those, only the ones that go towards the camera. And some are going to go and hit the mostly closed blades of the aperture and bounce off and go somewhere else, right? We don't care about those ones so much. The ones we do care about are those that bounce off in such a way that they go exactly through the mostly closed aperture. And when they hit the sensor in the back, they're going to register, right? So this light bounces off here, and it picks up this green and makes a spot here, right? It might bounce off this green here and make a spot here. Now, because most of these rays are bouncing off, we're only emitting from each ray that bounces off the tree, happens to make it through here and hits, all the other ones are going to bounce off here or go elsewhere. So it's only going to emit tiny clusters and give us very fine dots in here, right? Right where they need to be, because this is mostly closed and most are bouncing off this. So that's okay. We might have some that bounce off this red hat and bring the color red in, and of course, once again, some will bounce off this, whatever. But the ones that bounce off and then come through here, they'll land right where they need to be. So once again, we're getting very fine dots because this aperture is mostly closed. And this is going to give us a very sharp image, right? Because of this 1-to-1 ratio of it emitting only small clusters of light rays. The image will, of course, be upside down. So we're going to get a very sharp image, just kind of upside down. The camera reverses it much like our eyes, right? So it's basically going to come through and record this image. Now, looking at the total image here, we could say the tree, the top one that will make it through this aperture will hit about there, and the bottom one that's brown, if it bounces off at the right angle to come through the aperture, it's going to hit right about there. So basically our image is going to be like this, upside down. From there to our top ray. Now, looking at these two sizes here as far as our sensors. Now, the size of the image isn't changing. It's coming through this lens based on the angle light comes through and how close the aperture is, right? And how long the lens barrel is, and how curved our glass is, a lot of factors. So the size of the image here isn't changing, but the ability to record it is. Is this green one going to get the whole image? Well, look, the image is falling. If we go backwards and figure out the top of the tree comes through here, so it's definitely within this green full frame area, right? Now, the size of the image isn't changing, but how much of it's getting recorded on the crop sensor, the blue one? Is this outside stuff getting recorded? No. So if you look at the blue area here, without the image size changing from the lens itself, but just where it gets recorded, we're basically going to end up with just this much of the image, right? And if we copy that and paste that, let's see if I can get just that part. Okay. So look at that. Do you see how the image size isn't smaller as far as the lens is concerned? It's going to be the same on either of these, but we're only able to capture this much of it, right? Does that kind of make sense to everyone about the crop sensor and full sensor thing, right? So this is where our natural magnification comes from. We're catching a smaller part of the image, but at the same amount of megapixels. So usually a crop sensor will be like, say, 23 megapixels, and that smaller, or the full frame will be 23 megapixels, and the crop also is. So we have the same amount of pixels, it's just getting a smaller image. So the resolution is the same, but the size is magnified because it's the same amount of pixels, but a smaller part of the image, right? So if a bird were in the middle, there'd be no stuff around it as far as background. It would just be focused in on the bird, hence the natural magnification. Okay, let's go back to this. We're going to go back to our folks here. Let me erase these two layers. Now we're going to open up this aperture. So now we're going to say that it has opened up to f1.8. So that's going to be a pretty wide open aperture here. I'm going to go ahead and erase the middle here. So this is open about all the way now. So now we're at f1.8. And just remember that the smaller that number, the more open the aperture is. So this is going to cause a few things. This is going to cause, number one, shallow depth of field, aka wherever our plane of focus is. And let's make a new layer here and just say that our plane of focus happens to fall right on the sky. So we'll go ahead and draw this line perpendicular to the guy, and when we use our focus, this is that infinitely thin plane perpendicular to the camera, right? That is a perfect focus. Okay, so everything here is really in focus. Now, when we're at f22, because we're emitting small clusters of light rays, and we know that the higher the number and the more closed the aperture is, the deeper the depth of field is. And by that I mean, from this point of focus, a further distance we go in both directions is going to stay sharper for longer, right? So it'd be sharp all the way out to here and all the way out to the horizon line, right, going that direction. Now that we've gone down to f1.8, from our area of focus, it's only going to be about 1 inch this way and 1 inch this way that is actually fully in focus. After that, it starts to get blurry, right about there and there. And from there, it just gets more and more blurry in both directions. Now, the reason for that is because now that this is really open, we're not getting those small clusters of light rays. So now, when we have these light rays bouncing off, so let's say that one hits the tree right here, like we talked about before. And before, when they came over here, most of them bounced off these blades in the aperture, and the f-stop that were closed. But now, a whole bunch of them are going to be able to bounce through here. So this one spot on the tree that should translate to 1 pixel in the final image is actually going to get recorded in a whole bunch of places now. So light's bouncing off this one spot. And this one green pixel here is going to be recorded here, 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 basically all these spots along here, right? So we're going to have a whole bunch of these random green pixels instead of a 1-to-1 ratio. Now we have a piece of light bounce off of the next spot. Same thing here is going to bounce off, and it's able to come through here and hit in a whole bunch of places because this is so open. So for the next spot on the tree, same thing. It's just being recorded in a bunch of random places. Now for our hat. Same thing, it's going to bounce off, get recorded up here, here, etc. Now the one saving grace, the reason that we can get at least one small area in focus when the aperture is open is because we're able to focus this lens, and we change the distance between two lenses to bring what's in focus. As it goes through a lens, it's going to bend and it's going to get pulled back into sharp dots. So like these ones would get pulled back into sharp dots, but it only affects the plane of focus when we have a low aperture. The rest of these, unlike this tree for instance, they are going to come out and they'll get bent, but they're not going to get bent to come back to a fine point. They're going to come back to an area, right? And this is where we get the circles of confusion. This is also why the background and foreground in shallow depth of field pictures looks blurry, because this area of focus is the only thing that's bringing some of these points back to a certain point. But for the rest of these things, the foreground, background, it's able to come through the aperture in a whole bunch of different spots here and get recorded in a whole bunch of different spots. So it's not going to be sharp. So a circle of confusion is knowing that we have these larger dots here. Also, circle of confusion, like if a light ray hits directly, We'll choose another color for that. Let's do our light blue. So if a light ray bounces off and it hits pretty directly, it's going to hit like a point. But if it bounces off this aperture of the inside lens barrel and hits at an angle, much like a flashlight, when you point a flashlight directly at something, it makes a circle of light. But if you hold it at an angle, it's like a flashlight pointed directly makes this. But if you hold it at an angle, so kind of draw the flashlight there. If it's held at an angle, it tends to go out and shine at an angle like that. It spreads out and widens. So the same thing's going to happen here if we have light bounce around off the inside of the lens barrel and coming at an angle. So between these things is going to cause this to be a lot blurrier, and it's going to cause our shallow depth of field. So the more closed up the aperture is, the fewer rays of light it emits from each point, and the sharper the final image.